this person M2, this person let it be M3. First M2 will walk, no? Because of that there'll be displacement of Planck. And similarly, what's happened? M3, both are moving. The person begins to walk on a plank. Both are moving simultaneously. We are just taking the problem in two-dimensional motion. Okay, just carry on like first person X will take it. So every time drawing diagram and all will be very problematic for you. So what you should do, M3 delta X3 plus M1 delta X1 equals 0. Will I agree this formula? Now what is the system now? M1 plus M2, you have to take the system. So this is the displacement of the Planck along y-axis. Look at the formula M1 plus M2. When M3 is walking, no? So what is the mass, like a person M2 and mass of the person, that should be considered here. What is delta X3? Displacement of person. So let's go for like this. X31 equal to X3 bar minus X1 bar. Let me take. What is the displacement of person 3 with respect to Planck? Plus L. Displacement of Planck, the displacement of the person, we don't know this. And what is X1? X1 is what? Delta X1. What shall we do? We know it will shift towards left, no? If you know sign, okay, put it or else leave it here. So this is delta X1. Leave it, don't put any sign. So now what is X3 bar is equal to, or here only, L plus delta X1 bar equal to X3 bar. What is X3 bar? X3 bar is what? Delta X3 bar. Symbols, you'll get confused. So directly let me bring in terms of this one. So I'll substitute this. This is L bar, no? So, okay, there's bars, I'll take it. It'll be easy for you. Again, I cap, J cap you have to bring. Things will be. It is understood along X, along Y we are doing. So this should be equal to M3. I'll substitute here. M3 L plus delta X1 plus M1 plus M2 delta X1 so this will be M3L plus M1 plus M2 plus M3 delta X1 equal to 0. So what is delta X1? Minus M3L by M1 plus M2. Some of you are asking sign. What do you mean by delta X1 negative? The Planck will get displaced along negative x-axis. I'm not sure about sign, no. So therefore, don't if you are putting here, if you put minus delta, I know sir, Planck will shift. Put minus delta X1, you'll end up here positive. Are you able to understand? No? So the unknown thing, better don't keep sign. The unknown thing, don't keep sign here. So substitute directly. Just the only thing is what you should predict. In what direction the displacement of person with respect to Planck. Only that should be substituted. Mass of the person and second person, M1 and M2, both are there on the Planck. This person walks or pen. What is the other mass that will undergo displacement? M1 and M2 also should move along x-axis. Are you able to understand this? Okay, this we got it now. Now similarly for along y-axis. No, M1 and M2, no? No, similarly for person Y, person M2 is moving along y-axis, so this should be M2 delta y2 should be equal to M1 plus M3 into delta y. Delta y1 with respect to Planck I'm taking here now. Now again go for the same formula. Displacement of 2 with respect to 3. 2 with respect to 1. So this should be equal to x2 minus x1. This is a generalized formula. Now what is the displacement of 2 with respect to Planck? You will cover a distance L. I am taking this direction as positive, this direction as positive. I don't know this, how much the person has with respect to ground. Okay, leave it. That of the Planck, we don't know this, leave it here. Now calculate, so what is L plus delta x1 equal to delta x2. Substitute this value, m2 along y-axis, y2. Please wait for in between, wait for total problem. Once it get over, you'll get it that one. So in between, if you ask it, it'll be, because you wait for the end of the problem. After seeing the end of the problem, then you can really ask thing that one. Along y-axis, no? So m2, so delta y2. So delta y2 is what? L plus delta y1 plus m1 plus m3. So what is delta y1? Displacement of Planck along y-axis should be minus m2l by m1 plus m2 plus m3. What is this? What you should call displacement of Planck along x-axis. And what is this? Displacement of Planck along y-axis. Is asking total displacement. What you should do? Vector sum of this. The total displacement should be the vector sum of this. S should be equal to magnitude of displacement is asking. So delta x1 whole square delta y1 whole square. Two-dimensional also it will come. It's not that only one dimension. So what is the displacement of magnitude of displacement of Planck? Okay, now why m1 plus m2? When person, you just assume that person 3 is walking, then what happens? Person 2 will be there on Planck, no? Then person 2 plus person 1, they'll undergo displacement. Person 2 and Planck. Again, similarly, you assume m3 attached, let m2 be in motion. Then Planck m1 and the person m3 will undergo displacement. So that's why you have to take m1 plus m2 here. And this you make observation. You'll get problems of two-dimensional, even three-dimensional also. Earlier what we took one dimension, here just brought two-dimensional. Symbols, this you take care about this one. If I can write only x3. X3 means again you'll think position. That's why delta x3, change in position of the person m3, change in position of m1 plus m2. The net force acting on system along x-axis is 0. So therefore center of mass will not undergo displacement. That's why we are bringing the delta x. Come for this.